Alright, so this recording is for section 4.8, so we're going to be doing some more applications of trig functions. So we're kind of adding to what we did in section 4.3, where we had just kind of the SOHCAHTOA applications. So there are definitely a good amount of problems in this section that are more of that. So I'm not going to do an example of the ones that are pretty much the same type of thing that we did in section 4.3. I'm just going to try to hit the ones that look a little bit different. So background information first, and I'm going to see, I've been using, sometimes it's easier for me to use the type tool on here than to use the handwriting tool. So first thing that you have to remember is how to solve a right triangle. So when it says to solve the right triangle, all that means is to find all the missing sides and all the missing angles. So any of the directions where it says solve the right triangle, that's what we're going to need for you to do. So that's number one. Next thing that is going to be in the homework are what are called bearings. And bearings are what you use for plane paths, for boats, those types of things. But what we're really doing is we're using a north-south line and kind of talking about the direction that we're heading. So when you have a problem that involves bearings, the first thing we're going to do is we're going to start at either north or south. It'll say which, and then you rotate either to the east or to the west, the given number of degrees. And we will definitely do examples of this. So if you have no idea what I'm talking about when we do the example, hopefully that'll make a little bit more sense. So for instance, if you see a bearing that is labeled north 70 degrees east, that means to head north and then to rotate 70 degrees to the east. And so the way that that would look, get my pen tool back here rather than the typing tool, is, and it's going to bother me to not have the little, there. Now we've got the degree sign in there. But north 70 east would just mean, okay, first I'm going to travel to the north, and then the thing is going to rotate 70 degrees to the east, which means this is what the bearing would look like, because we went north and then we rotated. But it's written with the two different directions. Rather than saying 70 degrees northeast, they tell you which direction you're going first, and then the second direction is the one that tells you how many degrees you're actually rotating in the angle. Then the other type of problems that we're going to have, the last type, are problems that involve what we call simple harmonic motion. So the example that they use a lot is like something that's on a spring, for instance. If you were to pull it down and then release, it's going to bob up and down in what can be described as harmonic motion. So simple harmonic motion by definition is when we have an object that moves on a coordinate, can't spell, axis, such that its distance from the origin which we call D, at time t is given by one of the following equations. And it's going to depend based on which situation we're talking about, whether it's going to be sine or cosine. So it's either going to be a cosine, and it's not a w. I'm going to type, actually I'm just going to leave a space there, and I'll draw it in. But when we are dealing with harmonic motion, they use one of the Greek letters. Actually, I don't even remember which Greek letter it is that we're using, but it looks sort of like a W. So we're going to have a cosine WT. Maybe some of you that take physics, because I think they use this variable a lot in physics. We don't use it a lot in math, so I forget which Greek letter that is. But we're going to use the cosine model essentially when the equation is, now I'm having trouble getting it, there we go. If the motion that we're describing is furthest from its rest point when t is equal to 0. So meaning when your starting time, it's if the spring is fully stretched, then that's going to be a cosine model. If, and I'll just write it out here this time, and the way the Greek letter looks is it's kind of got like a little loop there in the middle. But we use the sine curve if the object is at rest when t equals 0. So there are going to be some problems in your homework that ask you to write the equation, so that's how you decide whether you're using sine or cosine. With the harmonic motion, interpreting it, the amplitude, as you might guess, is the absolute value of a. The period, since we're using sine and cosine, is going to be 2 pi divided by our Greek variable there. And then the frequency, which is something that they'll ask for, is actually just the reciprocal of the period. So 1 over the period, or you can do Greek letter divided by 2 pi. That would obviously give you the same thing there. So this is kind of all of our background information. The next thing we're going to do is go through a couple examples of what you're going to see in your homework. So the first things that you're going to see are problems that ask you to solve the right triangle. And I do not know what is wrong with my thing. I'm trying all of the different ways I know to change the color, because I usually, write some of it in one color and then my work in the other, but for some reason, all of the options, it's telling me that I've changed my color to red, but then it's not actually writing in red. So I don't know what the deal is, why I can't get the color to change. But anyway, so we're going to look at 2 of these types. Sorry about my horrible drawing skills there. Okay, so this is what we're looking at, and we are supposed to solve the right triangle, which, as we wrote at the top of the page, means that we need to find all the missing sides and angles. So of course it doesn't matter where you start. You should be able to find any of them using the given information. So I probably would start with finding the angle first, because that one's the easiest one to do. Because in this case, since I'm given 2 of the 3 angles, and I know this one's a right angle, that means that measure of angle A is simply going to equal 90 minus 52, which means that we're going to have 38 degrees. So measure of angle A is 38 degrees, we're done with the angles. So now I need to find side A and side C. Again, it does not matter which one you find first. So I'll just find A first since it comes first in the alphabet. So with relationship to the 52-degree angle, the A is the adjacent side, and the side that I know is the opposite side. So the trig function that uses both adjacent and opposite is tangent. So I'm going to set up tangent of 52 degrees equals opposite over adjacent. Now, you want to make sure, because I know we had problems in the last section where our calculator needed to be in radian mode. So here, obviously, we need our calculator in degree mode. So just make sure that you're paying attention to that. So here, if I want to solve for A, that means I'm going to switch the A with the tangent of 52. So A is going to equal 124 divided by the tangent of 52 degrees. So we're going to press that in on your calculator, again, making sure we're in degree mode. Most of the ones in your homework tell you to round angles to the nearest tenth and side lengths to the nearest hundredth, but just make sure you look at the directions. Sometimes they change it up. So if we went to the nearest hundredth here, we should get 96.88. So 2 of our 3 missing items are done. Now we just need side C. So in relationship to the 52-degree angle, C is the hypotenuse. The 124 is the opposite. So that means I'm going to use the sine of 52 degrees equals 124 opposite over hypotenuse. So C is going to be 124 divided by the sine of 52 degrees. And again, make sure it's in degree mode, and then you can just divide this out in your calculator. I believe that you should get approximately 157.36. All right, we're going to look at one more of this type. So this one's different because instead of being given 2 angles and 1 side, I'm given just the right angle and then 2 sides. So my approach is going to be a little bit different on this one. Again, it doesn't really matter which thing you find first. You can find all of them. I probably would find the missing side first using the Pythagorean Theorem. So the hypotenuse is 150. So 150 squared should equal 126 squared plus b squared. So 150 squared gives me 22,500. 126 squared gives me 15,876. So subtract on both sides, and that gives me 6,624 as my b squared. And then I square root it to find the value of b, which to the nearest hundredth is about 81.39. Now, since I don't know either of the acute angles, I can't obviously use subtraction like I did in A. I'm going to have to use my SOHCAHTOA. So for angle A, if I want to find it first, the 126 is the opposite side and the 150 is the hypotenuse. So that means the sine of angle A is 126 over 150. So that means that the measure of angle A, I'm going to find by doing the inverse sine of 126 over 150. Again, important since we want the angle in degree measure that you have your calculator in degree mode. So if you do inverse sine of 126 over 150, and again, most of the ones in the book are going to say to round angles to the nearest tenth, sides to the nearest hundredth. So we would go 57.1 degrees on A. And then B, you have a choice. You could do inverse cosine of 126 over 150, Or since we know that they have to be complementary, we can just do measure of angle B equals 90 minus the 57.1. Either way, you should get 32.9 degrees for the measure of angle B. All right, next one. I think I'm going to type this one. It's a word problem for bearings here. It's not what I wanted to do. I was trying to find the type tool, but apparently it's not coming up. I'm having all kinds of issues with my software here today. So I'll just use the messy pen handwriting. So situation we have here is two airports that are 52 miles apart on a north-south line. The south airport sees a plane at a bearing of north 34 degrees west. The north airport sees the same plane at a bearing of south 56 degrees west. And then the question we want to answer is how far is the plane from the north airport? I'm really sorry that I can't use different colors. I'm gonna have to, after I do this video, shut everything down and maybe restart it because I'm not sure what its issue is. See, I'll show you. It even says that I'm using red. Switch, red, maraschino, cantaloupe, and it still is using black. So the first thing that we should obviously do here is draw a picture. So we know that our two airports, we're calling them north and south. So we'll just draw them here. And we know that this is 52 miles because they are 52 miles apart. So it says that the south airport sees the plane at a bearing of north 34 degrees west. So that means from the south airport, I'm heading to the north, so I'm going this direction, and then I'm going to turn to the west, and I am turning 34 degrees. So this is 34 degrees. Then it says that the north airport, so my plane is over here now, sees the same plane at a bearing of south 56 degrees west. So that means from the north airport, which is right here, I'm going to go south, but then I'm going to turn 56 degrees to the west. And what we want to find is how far the plane is from the north airport. So this is going to be my x. Now, what we have here, and this is very nice of them to do, we'll have some ones that don't work out this nicely will happen maybe when we do law of sines and cosines. But 34 and 56 are complementary. They add to 90 degrees. So that means that this angle right here is a right angle. at the plane where those two bearings meet. So that is obviously extremely helpful to us in solving this problem, makes it a lot easier. So the x then is my side that I don't know. The 52 is the side that I do. So you have two choices here because we can use the 34-degree angle or we can use the 56-degree angle. It doesn't really matter which. So if I choose to use the 34, the x is the opposite side and the 52 is the hypotenuse. So that means I would be using the sine. So the sine of 34 degrees equals x over 52, which means to get x, we're just going to multiply both sides by 52. So 52 sine of 34 degrees. And we can just put that right into our calculator as long as it's in degree mode. And usually on these word problems, they'll say like round to the nearest whole number. So in this case, we would probably say approximately 29 miles because we get like 29.08 or something similar to that. Okay, last one is harmonic motion. So we're given an object and we're told that it moves in simple harmonic motion. With d, the distance, equal to -3 times the cosine of 3 pi over 4t, where t is in seconds and d is in inches. And what they want us to find, and this is typical of a lot of the problems in the homework, is they want us to find what they call the maximum displacement, the frequency, and the time required for one cycle. Okay, so again, I've said this before, but I'll say it again. The book is extremely readable. So if you are having trouble understanding the harmonic motion, really, if you read through the part of it in the book, it's pretty good at explaining it. But maximum displacement means like how far from its rest place does it go? So the furthest amount that it goes. So this really is just the amplitude because the amplitude is going to be the furthest away from the start point that we end up with. So that's really actually a very easy question. Our A value is -3, so that means we're going to do the absolute value of -3, which is 3. So our max displacement here then would be 3 inches. I'm actually going to do the frequency last because, as we wrote in our notes, frequency is 1 over the period or the reciprocal of the period, and C is asking for the period because that's what time required for one cycle is. So the period is 2 pi divided by our Greek letter, which in this case is 3 pi over 4. So we have 2 pi. And we're dividing it by 3 pi over 4, which means really we're multiplying it by 4 over 3 pi. So give this a denominator of 1. So the pi's are going to cancel. I end up with 8/3, which you can write it this way if you want. Time required for one cycle, you can say 8/3 seconds. It probably would make a little more sense in this real life situation to say like 2 and 2/3 seconds. But the 8/3 is an acceptable answer. Frequency is the reciprocal of the period. So instead of 8 over 3, it's 3 over 8. And the label here, that just means the frequency means how many cycles are you completing per second. So if one cycle is 2 2/3 seconds, that means we're only completing 3/8 of a cycle per second, and that would be our frequency. Okay, I think that should be enough to hopefully give you an idea of the stuff that's new. Again, like I said earlier, there are some word problems that are similar to ones that we did in 4.3, where we're just using SOHCAHTOA, using your inverse, sine, cosine, tangent, using your SOHCAHTOA. So I think that should give you a pretty good start. And make sure you check out the other stuff on Google Classroom, because I did put up keys for your homework, so you can look at mine. Again, make sure that you help each other, and if you are pretty sure I made a mistake, then that's fine. If you agree, then you're probably right.